Hello everyone, welcome to Creative Point. Today we have another instrument. This is called dial indicator. In this video we are going to test how we can use dial indicator. This is our main dial. As you see, this is the brand of the dial indicator. As you see, this is the upper one is called the bezel, and we can this is the plunger of dial indicator, and the downside, this is the contact point. As you see, there is a deviation. There is a small deviation, that is one deviation equal to 0.0 mm, and there is markers. We can set the marker so that we can check how much deviation from where to where the plunger is moved through the contact point. Okay, then we fix, and this is the adjustment. This is so that the steam bezel cannot move, so that this is installed. We for accurate tolerance, we have to fix the bezel so that it cannot be moved and our value is correct. So that's why we have to fix the stop point so that the bezel cannot move. This is used so that we can fix the bezel. Okay, when we type after fixing the bezel through the stopper, then we have to make it 0 through the bezel, and then we have to adjust the marker so that we know from where we can start our reading. And as you see, in dial indicator there is a small dial is there. There is numbering from 0 to 10. That means if the dial is moved from 0 to 10, 30, 20, 40, 50, and from 0 to 90, after 0, that is one round, clockwise round equal to 1 mm of the tolerance. Okay, before testing for the dial indicator through the tolerance, we have to keep it in the middle position so that the indicator move both direction, clockwise or anti-clockwise, so that we know the perfect reading through the dial indicator. This is the stand of the dial indicator. This is used to fix one reference point. We have to keep the stand where there is no movement. We have to fix in stationary point so that there is no movement. And this stand, there is magnet. Okay, when we fix this stand where there is no movement, then we check manually rotating the equipment or shaft so that we know how much tolerance is coming. These are the stopper. We can fix the stopper so that after that we make it 0 so that the dial cannot be moved. And this dial indicator is range from 0 to 10 mm movement. Before starting the reading, we have to make sure the plunger in middle position so that it can move through downward direction and upward, both directions, so that we know how much tolerance for the shaft or for any rotating equipment. We have to make sure the plunger or contact point in the middle of the in middle position. Okay, for the correct reading of any tolerance, we have to make sure the contact point or plunger in perpendicular to the axis of rotation. Okay, if that contact point is not in perpendicular direction, our reading is not correct. That's why for correct reading we have to check the contact point. After fixing all of these, then as you see in a small dial, when we move from in clockwise revolutions, one revolution is give you the 1 mm of tolerance. Okay, when either in a clockwise revolution or anti-clockwise revolution, they give you the downward and upward movement of the shaft or any rotating equipment. And this give you from 0 to 10 mm of tolerance. Okay, Basically, dial indicator used to calculate how much runout for the shaft or how much tolerance is coming throughout this rotating equipment. Now we have one example. The graduation is 0.1 mm. Our pieces is 20 mm. Okay. Now for the counter clockwise direction, the pointer is moved one in a small dial. There is one rotation, and after there is pointer in 29 mm. Okay, 0.29 mm. That means 29 multiplied by 0.01. That means total is coming 1.29. The total measurement is 21.29 because there is one clockwise rotation. That's why there is 1 mm. This is the actual measurement of this workpiece. Okay. Now we have first example. In first example, there is one complete counterclockwise rotation. After that, the pointer is it is in 5. Okay. The 5 become the total is 100. That means 100 minus 5. That means that is 95. Okay. That's why that 95 is multiplied by 0.01. That's why 0.95, and that 95.95 plus 1 equal to 1.95. That means the total is 1.95 is smaller because the in counterclockwise the pointer is going downside. That's why that is in smaller. Okay, it is only in counterclockwise. In second example, the reference point in the middle one, that is the reference point 20 mm. Okay, the last one in the right hand side, as you see, there is one complete clockwise rotation, and after that the pointer in 34. Okay, that means the 34 multiplied by 0.01, that means 0.34. Okay, and there is one clockwise rotation, that means 1 plus 0.34 mm. That means total is 20 plus 1 plus 0.34. It means total is 21.34. That means our reference larger than 1.34 because the 1.30 mm is larger than the original workpiece. Okay. So please like and subscribe Creative Point. In this channel we are going to introduce new technical instrument or any technical things we are going to upload in this channel. So please like, share and subscribe so that you know everything quick and easy way to understand everything. Thank you for watching Creative Point. Have a nice day.